Hi guys, welcome to the lesson on chemical tests. Today we're going to specifically look at the gas tests, and we're also going to look at the flame tests. So this is the chemical analysis topic. For tests of gases, remember we have different ways of collecting them. We can use a gas syringe, which is probably your best technique, because then even if the gas is soluble in water, it can be collected and is very accurate. The other method is to collect over water, so if the gas is not soluble in water. So chlorine will not be suitable for this. So these are the tests you have to know. For hydrogen, it's a lit splint with a squeaky pop. So the reaction going on is actually that the H2 is combining with the oxygen in the atmosphere to make H2O. Okay, so if I just put a half here, it's balanced. So lit or burning splint. Now for the oxygen test, you would put a glowing splint at the top. So oxygen is less dense than air, so it rises. So a glowing splint is when you have your splint lit, blow it out, and then immediately stick it into the test tube. That would then relight. Carbon dioxide, you bubble it through lime water. So if it makes CO2, say any carbonate, the CO2 goes into this delivery tube and it goes down because the CO2 is more dense than air, so you have to point it down. And then it will collect in here and bubble through, and it will turn like this, milky or cloudy. Now, lime water, now you have to learn this, is a colorless solution of calcium hydroxide. It is not lime. So when these two combine, they're going to combine with the CO2 to make a calcium carbonate plus water. The calcium carbonate is the white precipitate that you see as the milky observation. Importantly, this is a neutralization type of reaction because CO2 is an acidic gas. Finally, we have the ammonia gas test and the chlorine gas test. So the ammonia gas test, what you do is you take a compound that contains ammonium ions in it. So for example, we can use ammonium chloride plus sodium hydroxide. Okay. When you add these two together, it's going to form ammonia gas plus NaCl plus water. And this gas here is the one you test for, because that is when that is produced. So when you heat this solution up, so these are both AQ, when the ammonia gas gets released, you take some damp red litmus. It must be damp and it must be red, because then it will turn blue, because ammonia is a base. It's an alkaline gas as well. It's soluble in water, so it's also an alkaline. You need the dampness in order for the NH3 to actually react with the water to express its hydroxide ions, if you like. Okay, NH3 plus water. It will form your NH4 plus, which is your ammonium ion plus OH minus. And that was what we're going to make it blue. So it must be damp, otherwise it doesn't work. So NH3 is soluble in water. That's the simple GCSE notion. Lastly, we have the chlorine gas test. For the chlorine gas, very simple. If chlorine gas is produced, it will rise up, less dense than air. You put some damp blue litmus, and the damp blue litmus will turn red initially because it forms HCl, but then it will bleach white. So ultimately, you just need to say damp blue litmus paper turns white. For those of you that want a bit of an extension, the chlorine reacts with water to form HCl and HClO. Okay, that is the interesting thing. This makes it red and this makes it white because HClO is the bleaching agent. You should also know that this chlorine is used in swimming pools as a disinfectant. Okay, so these are your gas tests. Learn them well. They're easy marks. Next, we look at the flame tests. Now, how to carry out the flame test? So flame tests are used to test for positive metal ions, which actually produce a color. This is how it works. You take a nichrome wire You dip it into some hydrochloric acid. You dip it back into the flame on the hottest part, which is the top of the middle, so it's the top of the inner blue cone. Okay, you must have an open air hole. And what will happen is you'll need to clean the wire in that fashion. So normally, if it produces a color, you have to keep cleaning it in the concentrated acid. So you keep dipping it in the acid and dipping it back into the flame until it's clean. Once it's clean, you dip it but you know it's clean by not producing any color. You then dip it back into your acid. Then you dip it into the salt that you're trying to test, whichever that contains the metal ion, the salt, because you can't just have a metal ion floating. So say you're testing for sodium ions, you might have to have some sodium chloride here. By making the wire wet, it will then allow the salt to stick, and then you put it into your flame and you observe the color. That's the gist of it. Now, the finer detail points would be here. Clean nichrome wire by dipping into concentrated HCl and putting into flame. Dip nichrome wire into acid and into sample, then into the roaring blue flame. You get a mark for using the right flame. Special points on the nichrome wire and why it's used are that it is unreactive, it doesn't produce a color, and it has a high melting point. You can also use a platinum wire, but it's more expensive. This one is an alloy containing nickel and chromium. Okay, now the colors. These are the colors you observe for the ions. Now these are going to be the Edexcel colors. And to do 2-in-1, I'm going to do the AQA colors right here as well. So you can see them side by side, whatever is relevant to your syllabus. As you can see, they have a huge similarity. Sodium is yellow, sodium is yellow. Potassium is lilac, potassium is lilac. Calcium is orange-red, calcium is orange-red. Copper is blue-green, copper is green, slight difference. And another difference is that in Edexcel, people say lithium ions are red. Here they say lithium compounds are crimson. Okay, so a slight variation. Just learn whatever is relevant to you, so you can please the examiner. Okay. That's taken exactly from the syllabus, by the way. Now, some other important points to mention is, what's the problem if the sample is contaminated? Well, then there'll be a mixture of metal ions, which will mean the flame colors could be masked, and one color will dominate the other color. So that is obviously going to be an issue. I'm just thinking, is there any more flame tests? No, there isn't. So that actually brings an end to flame test lesson. And in the next lesson, we're going to look at how to test for positive ions. And again, we're going to do everybody together, Edexcel and AQA. Okay, and I'll tell you which ones you need to know for which one. So see you next time for part 2 of the positive ion tests.